All right. Happy December, everyone, or the end of December. I can't believe 2024 has just gone by so fast. And here we are with our last multi-cloud happenings of 2024. We have a fantastic topic, and I know that we've been very fortunate this year to have Paul and Suzanne talk to us this year on many different sessions on DevOps and MLOps. And so today is no different. So let's go ahead and get started because I know that's why a lot of you are here to talk about DevOps. So my name, oh, Paul, next slide, please. I'm like arrowing down. Okay, hi. My name is Tammy Bednar, and I focus on our Exadata database service, our base database service, and multi-cloud as well. And also, of course, with me today is also Suzanne. Hey, Suzanne.
Hey Tammy, hey Paul.
Excellent. And of course, Paul Parkinson, our database architect, our developer evangelist and advocate. Hello, Paul.
Hello, guys.
All right, next slide. Let's get this party started today. Okay, of course, we have the safe harbor statement that says sometimes we may have some forward-looking direction. It's for informational purposes, and you're not allowed to write it in the contract because product managers cannot give you any information to write into your contract. Okay, let's keep going. All right, so let's start off with multi-cloud DevOps and MLOps. Okay, Paul, over to you.
All right. Thank you so much, Tammy. Super psyched to be talking about this. And I'm grateful to be on these sessions too, because it's a huge topic. And so this presentation today actually is going to be pretty high level because we're talking about DevOps and MLOps across multiple clouds. So it's a big topic. So um, I'm going to kind of begin and end by saying there are workshops that either exist or are being developed for everything I'm talking about here. And so we're going to cover a lot, but not go super deep on this presentation. So on that note, just talking about what, DevOps is in general, get a frame of reference here. So DevOps is this, collaborative approach. And that's just it. It's a number of developers and DevOps engineers and things like that, working to continuously integrate and deliver a product. So this is the cycle here. Wherever you happen to start in the infinite wheel here, you're doing your coding, you're doing your planning. Let's start there. You're coding, you're building it and putting it into a repo, you're testing it, you're releasing it, and depending on your different strategies, you're further testing it, and then you're deploying it to production. And as it operates, you're monitoring it, and then you begin the cycle again. Okay, so that's the basics of the DevOps cycle. And then as far as the relationship between DevOps and MLOps and LLM ops, it's the same idea. It's a kind of a specialized subset in a way, but as you see here with the diagram, there are overlaps. So you have a somewhat similar life cycle where you're, developing, deploying, analyzing, but you're doing it for your models. And then if they happen to be LLM, you're using, it's further specialized, further characteristics as far as this cycle. And then they also feed into each other. They have this relationship where you may have an application that's using a model. So you have your DevOps for the application, and it's picking up the latest promoted models. And so there's that, interrelationship between them. And then, as I say, MLOps has its own cycle where you're doing the data collection and cleaning. This is some of the difference between DevOps, of course, is that how very data centric MLOps is as far as the cleaning. If you talk to any data scientist, they know creating the models is fairly somewhat the easier part. The gathering and cleaning of the data and the tweaking of the models and things like that are the really powerful and difficult part maybe as well in the MLOps cycle here. So again, this, ensures this development life cycle. And then I'm going to keep returning to this kind of matrix here. I personally find this helpful, right down to the CLI commands as far as differentiating the different clouds. Differentiating the different clouds, but to be honest, seeing how much they are actually quite similar in a number of aspects. So, everybody has their CLI, everybody has their cloud network, whatever they may call it. There are different CI/CD services. And I'm going to go into these a bit more when I go more into GCP and AWS. But this just kind of gives you a layout of the different offerings. And as I say, I'll go into them more as we drill down on the topic. And so with that, I'm going to hand it over to Suzanne to talk about
That's
Davis.
great. Good. Thank you so much, Paul.
You got it.
Thank you. So I'm just going to briefly take you through what we're doing with Oracle Database at Google Cloud. So this is the second partnership that we forged after Azure, and the final one is at AWS, which Tammy will take us through. So next slide, please, Paul. So now that Paul has explained about the DevOps and the MLOps, let's just take a quick look at what Oracle Database at Google Cloud actually is. And we forged this partnership because we want our customers to have the best of breed of the technologies working together. And this is where we cement this whole principle of DevOps and MLOps, which we're running actually, in this case, in Google Cloud, connecting to the Oracle Database and Oracle Database at Azure. So we have two flavors. We have the Oracle Database at Google Cloud, Oracle Autonomous Serverless, and we have Oracle Exadata Database Service. These are actually running on OCI managed by Oracle, underpinned by the Exadata infrastructure. Now that Exadata infrastructure is running inside Google Cloud data centers. And this is very, very unique offering because really it is the very first time that these applications from Google can actually run the Oracle Autonomous Database and Oracle Exadata Database service with RAC and Data Guard and all the goodness that comes with it, including the Autonomous Recovery Service that we have here on the left. Now, on the right-hand side, we've got various Google applications. And what we want to do here is just call out some of these that are going to be relevant today for this presentation. And you know what, like I said before, for the first time, these applications are reaping the benefits of Autonomous and Exadata Database Service in a DevOps and MLOps deployment. So we can build out a modern CI/CD system. In order to do that, you first need to choose your tools and your services that are going to perform the main functions of the system. And then on the right, we're just going to go through a couple of these that are relevant. So on the Google Kubernetes engine, we are running the artifacts that are building the continuous integration that Paul's mentioned. This is going to provide the scaling, the health checking, the rollout methodologies for the workloads. And then for the continuous delivery, we're using Cloud Deploy in Google, which defines the rollout process of the cloud across the environments. And then, you know, like Paul has just gone through the whole process around that. You can roll back the failed changes. And Paul's going to go into more detail about the Google CI/CD flow next. So such applications that we would come across in Google would be, for example, Vertex AI platform, which is providing these purpose-built MLOps tools for data scientists and ML engineers to automate, standardize, and manage the machine learning projects. And this Vertex AI platform is, you know, has its tools to train, like Paul mentioned, to tune and deploy the ML models, which is the tough part. Google Gemini is a family of AI models, and the Vertex AI offers the latest access to these Gemini models from Google. So it's really, the Gemini is really about capable of understanding the inputs, combining the different types of information, and generating a wide variety of outputs. So when we couple this with the Oracle 23 AI database capabilities, which Paul is going to go through in a little bit more detail later, this is going to be a very, very powerful union for such a workload. Next slide, please, Paul. So like I just touched on, we've got the Oracle Autonomous Serverless service running here with Oracle Database at Google Cloud. And this is really to reduce administration. It is an absolutely fully managed Oracle Database fully managed Oracle Database. And that's going to automate your provisioning, your monitoring, your scaling, tuning, backups. So all of this provides, you know, your scale, security, resilience, as well as your built-in AI capabilities, which is very important for this topic. And this is going to massively reduce your operations and therefore your costs. So on the other side of the coin, we have Exadata Database Service, which runs Oracle Database natively in Google Cloud as well on the dedicated infrastructure. And that has the highest levels of performance, availability, security, and cost effectiveness. So the idea behind all of this is putting the Exadata infrastructure into the Google data centers so we can support your workloads with the lowest latency possible. So latency intensive applications can actually be migrated to, the cloud and run cloud native workloads in Google with the Oracle database, with Oracle Database at Azure. And Oracle machine learning has been inherently, present. The algorithms have been there a long time within the Oracle database for quite some years now. And we continue to build on these AI capabilities with 23AI, including vector search. And Oracle AI Vector Search is designed for artificial intelligence workloads. It stores vector embeddings, and these are mathematical representations of data points. And they describe semantic meaning behind content, such as Word document, audio tracks, and images, and allow you to query database and semantics rather than keywords. So Paul's going to take us through the whole machine learning ops cycle so we can really understand how this is working at a multi-cloud level. Next slide, please, Paul. Okay, so Tammy and I have done introductory presentations previously on the benefits of Oracle Database at whether this is at Azure, at Google Cloud, or at AWS. We're offering exactly the same benefits in terms of a solution for customers. And the whole message is we're running this very, very low latency for latency sensitive applications in microsecond round trip times. And this ensures that we've got the highest database performance, the highest scale and security. And you can use your rack and autonomous and Exadata database services with the applications, including the benefits of AI that I've just mentioned. So what we're trying to strive here is a seamless experience. It's a one place for monitoring, for operations, for billing. You as a customer would receive one unified bill. So from the commercials, we're offering quite a few benefits in sense of, you can actually use your Google Cloud commitments. You can have the Oracle database licenses at ULA, bring your own license benefits, as well as Oracle support rewards as well as collaborative support, which is essential when you're really deploying a workload across two clouds. So it doesn't matter where the issue is, we will identify and actually respond to that problem and reach its resolution. So we've got 4 regions for Oracle database at Google Cloud in Ashburn, Salt Lake City, and in EMEA, Frankfurt and London, with the roadmap ever growing. Next slide, please, Paul. Okay, so let's just very quickly, just high level, just go through the architecture that we're deploying here. So what we're doing here is we're showing that the application resources in a VPC of Google Cloud project, you see here on the very top left, is within a single zone of a Google Cloud region. And the Oracle Database at Google Cloud solution integrates into Google Cloud the networking and the Google Cloud Virtual Private Cloud access. An application subnet in the VPC connects using the OCI managed network to Oracle Database at Google Cloud, and this operates in an OCI child site located in the same Google Cloud region. And the Oracle Autonomous Database and Subnet and the Oracle Exadata Database Service Client and Backup subnets depicted here. They extend into the OCI tenancy VCN, into the OCI region, and are accessible to other resources in OCI. So again, like all the other Oracle database apps, we have the identity access management platforms integrated as well. And that provides, as a customer choice, you have the choice whether you want to actually deploy federated identity and access management, and you can deploy this across multiple regions to ensure that you have business continuity and cloud resilience. Next slide, please, Paul. So I'm going to hand over to you now, Paul. Now we've gone through Oracle Database at Google Cloud to take us through what DevOps means in Oracle Database at Google Cloud and how you're going to deploy that with Google Cloud and how it works. So thanks, Paul.
Yeah, awesome. Thank you. Yeah, that
Thanks.
joint, when you're working with these multiple cloud, I was just noticing that joint support aspect on the other slide.
Yeah.
Because when you are working with this, you do notice it's not just two clouds cobbled together. Yeah, it's very intense, especially like in the observability and things like that. It's
Exactly. It's so
Yeah.
critical. Yeah, yeah, exactly. It's engineered interoperability. Yeah.
Yep, exactly. So this is the grid I was mentioning I'm going to return to, and then highlighted here is GCP. So each of the, as I say, there are so many similarities with the clouds, really, and so that's why I can create this grid to show you. So the main CI/CD DevOps services in GCP are this cloud build and cloud deploy and really primarily cloud build. You can do everything with cloud build. And then cloud deploy, and I'll touch on this a bit more, is really, advanced deployment. So you can deploy with build, the service, but cloud deploy is this extremely robust system where you can do deployments to different types of applications and other services, and also do things like automatically sets up canary deployments and blue green and things like that for testing. So that's where cloud deploy excels. Again, some of this is like semantics with words. So OCI has DevOps, Azure that we covered this the other week. There's this called DevOps, but specifically pipelines is the name of what they're doing, the cloud build is doing as far as this DevOps lifecycle. And then, of course, we'll talk about Amazon a little bit later. And then I just want to get into, because we're talking about the tech with DevOps and MLOps here, but that's of course intertwined with the use cases. And as Suzanne was saying, we're seeing this, for example, Vertex AI and the Oracle database, that may be, the top everyone is looking at trying that or doing that. That combination is super powerful. But there are a number of different things depending on what you're trying to do, a number of different services between the two clouds. And so I'll just go over them very quickly here. So as far as app related, everyone has their functions, right? So these are the very quick pop, the VM fires up, it does an operation, maybe a couple seconds, adds two numbers, some math or something like that. Classic function service. And then basically everyone has their what OCI calls container instances, or Azure calls like an app service. And GCP calls their Cloud Run. And that is also serverless, but that's where you're bringing your own containers. And so it's managing your containers, and it pops up and you can run whatever containers you want, things like that. And then everyone has their sort of where it starts to become even more of a platform as a service like App Engine, where it's less and less that you have to manage is what it comes down to. But again, you're bringing containers. And my main point with all of this is this with all of these, you can connect to the Oracle database to use. So that's, it's completely relevant as far as in architecture in that way. And then you have the Kubernetes. So Kubernetes is the app related, you're using containers and things like that. So it's pretty much interoperable, things like that. But Kubernetes is, the definition of interoperable. If you're running a Kubernetes app on one cloud, it's going to be portable. Aside from small, details, it's the point of Kubernetes is that it's this open source cloud native standard. And so on GCP, that's referred to as GKE. Of course, Google were the ones that started Kubernetes in the first place. So that's going to be a very popular combination. And I keep coming back to Kubernetes because it's so popular and it's just increasingly so. So that's kind of the base for the app DevOps aspect. And then everyone has their data science platform. And that Vertex AI Gemini combination, Suzanne described it perfectly already, but the Gemini multimodal model and Vertex, what that provides, and then using the Oracle database is just that's the combination we're going to see so much of. And then, of course, I just put on the bottom column the fact that it's all co-located Oracle databases. Okay. So let's get into it. Again, I'm not going to go super low level, but this is the Google Cloud DevOps. And so what you're doing as far as the DevOps life cycle, you're writing your source and you're checking that source into some Git repo, into some repo. So the first part of the integration with any DevOps is you're giving permission to that repo. Well, actually, let me start at step zero. So generally, you will be during your DevOps lifecycle setting up, provisioning some kind of infrastructure and things like that, right? But in practice, and I say in practice because there are so many different ways to do DevOps. But what I'm showing is basically, the parts that everyone uses. This is the standard. But the variations are often in how much is set up ahead of time. So you may, as part of your DevOps lifecycle, be provisioning container databases that you do testing on, and then you get rid of those containers and you move to production. Or maybe you set up ahead of time a database and you're just doing, even right down to schema level. You create a schema, you test against that schema, that database stays. There are all these different variations. And of course, again, that's with the Oracle database. You have the, autonomous, you have the containers, every kind of different combination for that. So generally, though, you do see where some infrastructure is set up ahead of time. So step zero would be you provision an Oracle database, you provision your Kubernetes, um, and then, if that's dev, QA, prod, whatever the flavors may be, generally, you're setting up something ahead of time, okay, and then adjusting as you go through this cycle. So I just want to set that up as and so again, you're checking in code. That is triggering a build. So whenever something is checked in to the Git repo, that triggers the build back in on your pipeline. And again, their product is Cloud Build. Then you're doing all your security scanning and things like that against your build, which is creating a container. So you're doing your build, that creates a container image. You're doing all of the various scanning on that. All along this, it's really DevSecOps because there's security along each step of this. And that's why I say I'm trying to keep this high level because there's just so much involved. But you have security all along the way. I'm gonna make that, you're checking your dependencies during the build. You're scanning your container that you've created from the build, and you're putting that container into a container repo. And every cloud has a container repo, and you've set that up as part of step zero as well. Okay. So with the database, it's a few clicks to set up. At Kubernetes, no matter what the cloud, it's usually a few steps to, a few clicks to set up, or if you're using Terraform, they're on the same cloud network so they can communicate with each other. You've set up your container repo, which is again where your builds are being put, and then you're deploying. And again, you're deploying generally to a testing environment first. So you've done your testing during build. Now you're doing your integration testing or whatever you want to call it after the deploy. And then when you're ready for production, you actually are deploying it into production. And that's what I mentioned, the cloud service at Google, where you can send it to all these different runtimes, the functions, compute engine, Kubernetes, etc. Okay. And then the final step in that DevOps life cycle is the observability. And I'm going to go into that in more detail because that's an area I mean, there are a number of areas, but that's an area that Oracle's really, really strong in particular with the database and in particular with multi-cloud. So, um, just one more slide on this topic, actually, just to go from a high level to a real level, low level code snippets. At the end of the day, your pipeline is a YAML file. So Amazon is a little different with their DevOps setup, but all the other cloud vendors have some kind of OCI DevOps YAML or Azure DevOps YAML, or for GCP, it's Cloud Build YAML. And it's really these steps that I just mentioned. This is the lifecycle steps in text. You're grabbing it, you're maybe installing some dependencies, excuse me, running some tests, building the app, putting it into the repo, deploying it to Kubernetes. It's laid down in these steps. And then I'll show kind of the other side of it with Amazon because although these are so similar, they each have their kind of flavor or style. And you can tell in some they're expecting you to get into the editor more. And others like Amazon, they think you're going to, or they're kind of made it so you're in the console more. You're doing more of this visual. So either way, you can manipulate this text file, and this is generally what they all look like, okay? And then on the right-hand side, I just have a snippet as far as I'm using Java as an example because JDBC has a very robust SPI specification. And the JDBC guys have done a great job at Oracle. If you name it, OCI Vault, whatever the provider may be, they use this SPI to plug in, so it provides the utmost in security. So very quickly with Kubernetes as an example, the way Kubernetes usually works as far as credentials is that you have a secret in the Kubernetes cluster with your connection information. Now they've evolved to have a few different strategies, but even all of those strategies, whatever sidecar, whatever you're using, are not the optimal as far as security, which is what these SPIs provide. So you can actually provide the secret ID to your vault as part of your URL, and you get the information that way, rather than say bringing it into your environment, your containers environment, or bringing, like I say, another sidecar or something like that in. So I just bring this up as kind of the left side is your config for your DevOps pipeline. The right side is a very crucial part of your app for efficiency and security in that DevOps pipeline. And I just use Java JDBC as an example because it's a really nice one. It's very pluggable. You can swap out your wallets and passwords without messing with your Kubernetes cluster. So just to give you the idea of the implementation, these are two very key points. Okay. And with that, we're going to move on to AWS, and I'm going to let Tammy
All
do
right.
it.
Thanks, Paul. I appreciate that. All right. So yes, we're really excited to add to our multi-cloud solutions. And the next one is Oracle Database at AWS. And go ahead, next slide. So hopefully you heard about the Oracle Database at AWS solution, or you were able to join us at reInvent in Vegas just a few weeks ago. And I heard that that was quite successful, and we had a lot of activity going on at that particular conference. So just like Suzanne talked about Oracle Database at Google Cloud, we now have Oracle Database at AWS, which is providing the ability to bring your database services closer to your application. So with AWS, it is in more of a preview at the moment, and you are able to talk to your sales rep if you're interested in starting with the Exadata database service. And so we will also have autonomous database dedicated capability in AWS starting early in calendar year 2025. So we're really excited about this new offering that we're able to bring you on AWS, bringing your database sources, specifically your Oracle database sources and our services closer to your applications. And here you can see that AWS has quite a few innovative cloud services that we're really excited about to have better integration, to help you run your businesses much more successfully, much better. And I'm just really excited about all these partnerships that we've been working on really over the past year. So it's pretty amazing where we started in 2022, believe it or not, 2023, and then all of 2024 with all this innovation that has progressed during the year with all our partners. So I greatly appreciate working with all our partners. We really appreciate working with you as well. So let's go to the next slide, Paul. So as I mentioned, Oracle Database at AWS is going to start off with providing the Exadata database services today. So if you're interested in getting started with AWS, it is in a single region at the moment. Take a look. Go please talk to your sales rep about getting into the AWS solution. So we have our Exadata database service, our dedicated service where this is a co-managed service. And dedicated, of course, means that you have all the hardware dedicated just to you for all your different workloads as well. And the Exadata database service supports versions 19C and 23AI of the database. Coming, as I said, mentioned earlier, very soon will be our autonomous database dedicated. Now, if you have looked at our other multi-cloud solutions, we've had autonomous database serverless, right? With dedicated, I think what's going to be very unique for many customers, or if you haven't seen it before, you'll be able to run both Exadata database service VM clusters and autonomous database dedicated VM clusters on the same Exadata infrastructure. So that's going to make it really easy for you to start out with Exadata database service, provision an autonomous database dedicated VM cluster on the same Exadata infrastructure, and start testing out. If you've never used autonomous database with all its automation, I think you'll be really pleasantly surprised. If you're looking for a fully managed database service using our Oracle database, 19c and 23AI, that's coming to you very shortly. If you don't know about autonomous database and would like more information, please do reach out to your sales reps as well, and we're more than happy to talk to you about much of the capabilities. As Suzanne mentioned, of course, running 23AI, we now have all the new, modern, all those new features of the Oracle database. One of those being vector search capability and Exadata being able to use our offloading capability, or I should say our algorithm, to be able to quickly return vector search queries very much more quickly on the Exadata platform than some of the other platforms you may have been testing out. I would love for you to test that out, so take a look for that. Okay, next slide. Okay, so I'm sorry, I forgot we were calling it a gated preview with Exadata Database Service. This is giving you full functionality. I think you saw this with Suzanne when she talked about at Google Cloud as well. We have full capabilities, including RAG, AI vector search, Application Express to very quickly develop applications. And we have one region now, and then there'll be additional regions added in AWS in 2025 as well. So we want to provide this experience, a seamless experience, being able to use the native AWS console and API experience to provision your Exadata infrastructure and the VM clusters. We also have been working with, of course, our partners to provide a single location for monitoring, for ops, for billing as well. We want to make it much easier for you to use this solution, because we know that you have your favorite applications. We want to use the Oracle database along with it on Exadata platform. We want to give you that solution for your business applications as well. You'll be able to leverage your existing investments using AWS private pricing agreements. You'll be able to license the Oracle database with a EULA or license included, or bring your own license. And of course, the nice thing is you get to use Oracle support rewards as well. You're actually getting money back from Oracle to make your support bill much cheaper. And if you haven't heard of Oracle support rewards before, please reach out to your Oracle representative for more information in that as well. As I said, the first region that we are launching AWS in is Northern Virginia, and we have more planned in 2025. All right, next slide, please, Paul. Okay, so this is the network architecture picture. I'm sure it looks very familiar if you've seen our Oracle database at Azure and our Oracle database at Google Cloud. This is our Oracle database at AWS. As you can see within the AWS region, we have a OCI child region. And we have a new concept called an ODB network. It's the Oracle Database Network, where you set up the VPC, and this becomes the Oracle Managed Network as well. So we do set up an AWS VPC, which will connect over into an an Oracle database VCN as well, where we have the client subnets and backup subnets, where you can take your applications and connect those directly into your Oracle Autonomous Database or your Exadata database service databases as well. So this just kind of gives you a bird's eye view. It's very high level of how we are co-locating our physical hardware into the AWS regions, making it being much closer to your applications, thus reducing the latency time between your applications and the database connections as well, but still being able and managed as an OCI resource, as well as being able to use other OCI resources and services as well at the same time. So we make it much simpler for you to use whatever you need in order to run your applications and businesses. Okay, next slide, please. I think we're over to you now, Paul.
All righty. Thank you so much, Sammy. So yeah, well, I'll move into the same for AWS. And this is the same chart again. And here the CI/CD is code pipeline. And the app related, again, Lambda for functions, that's famous. Fargate is they're more, similar to whichever cloud you're most familiar with, container instances or Cloud Run, wherever the case may be. And then Kubernetes is EKS, Elastic Kubernetes Service. And the data science platform is SageMaker. That has a couple of unique aspects, but again, these data science platforms have a lot of commonality. And then, of course, we're talking about the Oracle database. So, as I mentioned, they they're similar but different. So this is the basic the DevOps cycle, right? You have your code commit into the repo. Again, you do have that step zero. You set up your Kubernetes or whatever the case may be on Amazon. You set up your database. They're connected. You commit your code. It goes into code build. These are, subcomponents of code pipeline. And then that is sent over to wherever it may be. And then you can have code deploy go to your applications as far as Kubernetes and things like that. Okay. So same concept. And then again, in this case, in Amazon, it's a little bit unique, but the same process as you can see on the left, you're building out your pipeline. It's going into a JSON file, like Amazon's just a little different with things. And you can put that into your source code repo. So generally what you are doing is you're using, infrastructure as code. And by that, you're using, maybe Terraform to set things up. But another part of that is actually storing your pipelines in your Git repo with your source. So everything is self-contained. And so you're storing the YAML for the other cloud providers. It's a little different with Amazon. As I say, they're very kind of console driven, and the console is very nice. Um, but you're not exactly saving that YAML. You can save the scripts that fire off these workflows in your GitHub repo. So I just bring that up as a bit of difference and to explain why I'm showing the other side of things here, the console. But you would use the same principles as far as getting the credentials from whatever vault you may be using, using the different driver things driver features that have been added in the Oracle database. Okay. And then this is showing your editing in action. And as I say, all these screens are nice, but you'll see if you talk to any DevOps person, a lot of times you're going in and tweaking the scripts afterwards, right? So these consoles get better and better, but it's usually a combination of editing in action here and then looking at the underlying YAML or JSON and tweaking it. So what we see here is just that this is actually going to ECS in this case, and we're building it, and this is the cluster name and the service name, and that'll be added to the pipeline. And so it's all the same concepts. And then I just wanted to go into Liquibase. So I talked about, application source code changes. I talked about infrastructure as code changes in the repo, but then we also have as part of our CI/CD, the actual changes in the database. And so we have Liquibase and Flyway are the most common frameworks for that. And within the SQL CL tool, which is Oracle's, if you know SQL Plus, SQL CL is kind of a newer version with a bunch of functionality. It's the client for the Oracle database. Within that, there's a lot of functionality, including liquid-based support for the database. So this is quite powerful because this is not particularly easy. You know, a code application source is not particularly easy either to do versioning and all the CI/CD aspects. But when you're also bringing in database changes. So this SQL CL support, this liquid-based support, is very powerful. And you can use that even for versioning if you're using, as Tammy mentioned, that Application Express Apex. You can actually version that code using Liquibase as well. So there are a number of different ways to go about these database changes. For example, it can be part of an init container. So in Kubernetes, you have your deployments, your microservices, and they can have init containers that come up before the service does. So that makes sense. A lot of people do that. They have an init container so that it's part of the actual deployment of your microservice. Or you can put it right in the pipeline as I do now. So when you're running the pipeline, it's at before any of that stuff, you could do this liquid base. So as I say, there are little different variations, of course, in DevOps, but we know about the most popular ones in particular. But the whole thing with the Oracle database, as you may have noticed, and not to digress, but Andy Mendelson did a little talk on it the other day. You know, that our converged multi-purpose aspect of the Oracle database is just really amazing. And this isn't something new. This has been, 40 years of whenever a powerful, popular tech comes, the database jumps on it, incorporates it, and takes advantage of what's there already as far as, transactions, etc. All the different data types, workloads that we've talked about. So it really is, you really hit the ground running, put it that way, with using the Oracle database in DevOps and MLOps. And so just a couple other CI/CD tech topics here, where I've been talking about cloud vendor DevOps, but that's not to exclude, of course, things like Jenkins, Argo CD, if you're not familiar. If you're using Kubernetes, that's extremely popular for CI/CD and GitLab, okay? And then there's also Spinnaker that is used for, very popular, used for deployment, as I was saying, like advanced deployment such as canary blue-green testing, mirroring, things like that, across multiple cloud providers. So if you have an application and it seems the trend that if you're multi-cloud, you're maybe not just two clouds, you're three, four, that type of thing. That's why, this Spinnaker has become so popular. It deploys across multiple cloud providers. And everything I'm talking here about, even though I've been focused on the cloud vendors, applies to these. And then the last thing, a little topic I wanted to mention is platform engineering has become very popular. If you're not familiar, this is just the creating and maintaining of a range of tools to streamline dev deployment and operations. Okay, so these have become very popular. If you go to any, cloud native circles, platform engineering is a big one because of all this, the multi-cloud and all the different components and, all the different functionality out there. There's this whole layer of platform um, that has become very popular, big industry, if you will. And that includes automation, orchestration, monitoring, security, everything we're talking about, but kind of in a platform. So we're on top of that. And it also includes exactly what I've been talking about as far as observability, et cetera. So this all applies to platform engineering as well. That's my main point. So let me go into, again, this is so much content, but let me go into MLOps and do a fairly high level here. So the MLOps life cycle, as I mentioned earlier, it begins with the data collection, ingesting and cleaning that data. So again, every step of the way here, there's an advantage with using the Oracle database as far as ingesting and cleaning data, data pre-processing, so bringing data in from different resources. So the Oracle database can be one of those resources, or it can be doing the wrangling, bringing it in from other resources. So as you can see in the database, if you mess around with it, you can bring data in from all different sources as far as object store, all the PDFs. PDFs probably as in my experience, the number one use case for the vector searches and things like that. Um, and for MLOps in general, these PDFs. And then you train and tune the parameters. And I'll get into a bit more on these as I go into the technologies and products used. And then you test them, you deploy them, you collect your feedback, and you monitor them for data drift. Are the models, even if they were good at one point, because the data has changed so much over time, there's a drift, and so the models don't apply anymore. You make these adjustments and add functionality and then start the cycle over again. Okay. So every vendor has their data science services. We did a slightly deeper dive here in Multicloud Happenings on Azure's the other month. Um, and again, each is slightly similar, but it's the same concept. So you use these data science services to deploy and tune these models. And as I said, you can get the information from the Oracle database, or I'll explain how you can use the Oracle database more actively as well. Um, and then it can be used, ingesting information from data flow, et cetera. Okay. So basically, you're working with these data science services will bring up your CUDA environments, whatever you need. And then you're working with your notebooks, your Jupyter notebooks, et cetera. And generally, an MLOps, the same way a DevOps life cycle is kind of boils down to that script. You can see the life cycle in that YAML script. A lot of times, basically, it's the Jupyter Notebook. Steps in the Jupyter Notebook are a large part of the MLOps life cycle as far as developing and bringing data in, et cetera. Not all of them, but the actual notebooks are a huge part of this data science services. And then what has become very popular is the use, particularly with Kubernetes, is MLflow, and obviously kubeflow is prime for Kubernetes. So Kubernetes has been great for training and MLOps because you can bring in the different shapes of VMs and things like that. Uh, and they work together with data science platforms. As I mentioned with DevOps, the same thing is true with MLOps. There are a lot of different combinations, but very often you're using a data science service, but you're using MLflow or kubeflow for the points I mentioned here, for the tracking, for projects, and for the model deployment. So you can track versions as you see in the bottom left here. You have your different versions. It's a nice layout, so you're doing your development, things like that in your data science, and then you're using MLflow or kubeflow to track these versions and then monitor them and then promote them into deployment. Um, so that's very popular. Now we move to the Oracle database. Of course, the Oracle database has the nicety as far as data management that I just described when you're using these data science platforms. But we also have something called OML, Oracle Machine Learning, that predates basically all of everything I'm talking about here, which is the other thing that's just so great about the Oracle database is, so much has been in the database for decades, including this OML as an example. So it's just very hard. And ML is not something new. You can train your models in the database. And so this is this co-location, this multi-purpose aspect of bringing AI to your data just is manifest and exemplified in a number of different areas in the Oracle database. And OML is one. The other is the vector search that we keep talking about. And one of the reasons we do is, its popularity, of course, but you can create actual embeddings in the database and do the vector searches on them. So it's quick because it's right there. It's right next to your data. It's secure because you're not sending your data back and forth to create the embedding. So you're not sending it to Pinecone or something like that, and then it's coming back, and then you're doing your business logic. It's co-located there, and it's transactional. So when you're creating embeddings, querying on them, that action can be transactional, and that's a very unique feature. And so it's the same idea with this coming back to OML here, which as I say, has been in the database for decades. Your data is right in the database. And again, to the converged aspect, you can use whatever tools you were using over in any of these data science. So that's why I emphasize the Jupyter notebooks. That's the data scientists I don't know, main tool as if you're in data science, you know what I'm talking about. And you can run your Jupyter notebooks in the database. So it's awesome too because it's an actual execution environment in the database. You write your Jupyter notebooks, or you bring over Jupyter notebooks you had already. You run them right next to the data in the database. But you can actually just be doing this on a Chromebook or something because the execution environment of that Python is actually in the database. It fires up a VM, it executes the Jupyter notebook, and of course there are all these niceties with that. And then, it shuts down the VM and you come back to it. So it's great, really. And just having it in the database as well is nice. If you want to create a model, it's basically 3 clicks. You have a database table. You say, I want to monitor this field for anomalies, and I want to make a model off this table. It supports, it shows on here, auto ML. So it'll say, okay, this data is most appropriate for this model. I'm going to pick this model. I'm going to apply it. I'm going to create the model, and then I'm going to monitor it. And we've added in 23AI all of this monitoring and reporting capability for these models. So again, there are a number of different combinations you can use the Oracle database with in MLOps. Um, uh, and it's completely compatible to what you're doing. So if you're using Jupyter Notebooks and you're not using Oracle Database and you're like, okay, let me try Oracle Database, even though I'm using data science on CloudX and I'm using Kubeflow, that's not going to take you much time and you're going to get efficiency. And then only one other thing I'll add is that you can actually fire up GPU as well. So if you're using models in the database with OML, and in your Jupyter notebook, you're using a GPU model. You flick a switch to say this is a GPU model, and the database now is able to fire up the GPU support out of the box, as it says there. So pretty went on a little bit for that and got excited, but it really is super powerful for ML ops and super easy to manage as well because it's all in one spot. The last topic I'll go into is observability. As I alluded to earlier, we have a very powerful offerings in observability. So I'll just do this quickly. Basically, we have um, exporters for metrics, logs, and tracing, and as well as events, actually. But these are generally the 3 pillars of observability. They say metrics, logs, and tracing. And what's powerful about these is you can get whatever you want out of the database using SQL. So you can be very precise, in using, because you can use SQL and be very specific. So you can say, I want just a certain row in the alert log, only the certain metrics. So it's very efficient with all of this data in these systems, these complicated systems. And then the one very unique, only Oracle database has this feature is the tracing exporter. So when you're tracing these apps through the system, especially, you're using microservices, you have a million different pieces. Um, Observability in general becomes very important, but the tracing is important, and it's a trickier aspect because you need to carry an identifier through the system. And so usually when you look at observability tools, you'll see a trace and it ends at the Oracle database. And then it ends at the database, whatever the database may be. And then you need to take that ID, go over to the database and further look. Where we have the ability to take this open telemetry, it's all open telemetry standards based across Oracle, trace it into the database so you can trace all the way from the cell phone into the database. So that's just a short explanation of it. And here's a screen that shows the classic scenario of the application developer blames the database blames the network, and they both agree to just blame the network because it's this nebulous, this is the age-old flow. But here you can see for the first time, the application call here, the time spent on the network, and then the time spent in the database, and then what activities in the database itself, right down to the disk, whatever you want. So no one else has this. As I say, everyone else, it stops here. So you can't tell what's going on. So very powerful for observability. And then this is just an example of it in Grafana. I'm running long, I know. So this is just showing the fact that you can use it in Grafana, metrics, logs, tracing from right to left, drill down. So it's end to end. But of course, all of the different, and when this is why I was referring to when I referred to Suzanne mentioning how nice the integration is as far as multi-cloud. If you go into any of the monitoring products, um, in this, the far right one is Amazon, CloudWatch, the middle one is GCP, and then this top one is OCI. If you go into any of them, they're really nicely set up for observing your environment within the Oracle database within the DevOps and MLOps. Okay. And so with that, I could talk more, but I know I just I'll go on.
Thanks, Paul. Yeah, unfortunately, we're out of time.
Yes,
Go ahead and
thanks.
jump to the next slide. So here are some great links for how to get started. I will be posting a PDF of this, and you'll be able to access these links on how you can access the workshops and a lot of this other great material that Paul has here as well. So next slide, please. And I'll also post the recording and you can find it. We'll be able to find it on Ask Tom. So if you are into Slack, I know we don't have so many Slack channels anymore, but we do have a public Slack channel where you can join us about other discussions on our database cloud services as well. I want to thank you again all very much for joining us today. We really appreciate all your attendance over this year. And we look forward to continuing in 2025 with all these great solutions. And Paul, we had a great question from somebody looking for some specific use cases, and we'll look into creating those for you and bringing those to you in 2025 as well. So thank you all very much. Thank you, Paul. Thank you, Suzanne, for everything you've done. I really appreciate it. And with that, I'm going to wish everybody a very happy holidays and a fantastic new year. And we look forward to talking to you in 2025. All right. Thanks, everybody. Thanks. Bye.
Thank you. Bye-bye.